All right, we're going to take a look now at number 4 from these practice exercises on formatted I/O. I've just gone ahead and copied the exercise instructions here inside a file named exercise4.c. All right, assume that the following source code is inside the main function. So float, x, y, int I, then this call to scanf. So let's just go ahead. I've started this blank C program here. Right, I've included standard io.h because I'm using scanf, but this says let's assume we've declared 2 floating point variables, x and y, and then we've also declared an integer variable named I. So we've got scanf, and now inside this format string, we've got %f for float, %d for integer, %f for float, and now we've got the address of x, so x is a floating point number. So we're going to say, take the first thing you read, interpret it as floating point information. So go ahead, pattern match for a floating point number, and then store that in the variable x. Take the second thing you read, and you don't have to leave spaces in between these commas. I'm just doing that for readability. I want to store that in the int, so that's the address of I. All right, so it says, take the second item you read. I want you to look for an integer, and I want you to store that data in I, and then finally, %f says to read another floating point number, and we will store that in y. All right. So now we want to know if the user enters this. Let's put that down here in a comment. All right. If the user enters, yeah, let's make that a multi-line comment. We want to know what's stored in x, I, and y. Right. So the first thing is this is going to say, I want you to go out and look for a floating point number. So the user will have typed 12.3 space 45.6 space 789. So it's going to look at this and it's going to say, is a 1, could a 1 be part of the floating point number? Yes, it could. Well, basically, it's going to read the 1, the 2. It's going to see the decimal point. It's going to say, well, can the decimal point be part of a floating point number? Yes, it can. Basically, what it does is it looks at this whole thing. It reads this character by character, and it recognizes 12.3 as a floating point character. When it gets to this space, it says, nope, that doesn't match the pattern for a floating point character. So I'm going to take the numbers that the information that I already read, 12.3, and store that in x. And now it says, okay, now that I've done that successfully, I'm going to go ahead and look for an integer number. So the %d says look for an integer number. So it's sitting here and it's looking at this space. Remember, pattern matching for this, it skips over a leading white space. So it's going to skip over the blank space, and it's going to then read the number 4. Right? It's going to look at that and say, could that be part of an integer? Yes, it can. It'll read the 5. Does that look like an integer? And yes. We can see the next thing here in the pattern that looks like an integer is the 4, 5. As soon as this gets to the period, it says, oh, nope, that can't be part of an integer. So I'm going to take this good information, 4, 5, successfully read that, and store that in I. Now, remember, it's sitting here in this input buffer, right? When we type in the keyboard, this is sitting in an input buffer. It's going to look at the period and it's going to say, well, what am I trying to read now? Oh, I'm trying to read a floating point number. Can a floating point number start with a decimal point? Yes, it can. So it's going to read point and then 6. All of this looks like the floating point number. It gets to this blank space and says, nope, that's not part of a floating point number. So it's going to store 0.6, this information, 0.6, is going to store that in the variable y. It's going to leave out of, in this input string, the space, the 7, 8, and 9 is on red. Right, it's just sitting there in the stream. If our program doesn't try to read from the stream, we'll just eventually lose that information. We don't have to worry about that, losing that information now. All we wanted to do was we wanted to know what is stored in x, I, and y after the user types this information. All right, so one way we can do that is I'm going to use the debugger and do a run to cursor. So I put my cursor here, right? I want it to run all of the statements in the program until it gets to the cursor. So if I right click and say run to cursor, if I haven't built a program, it goes ahead and compiles and builds. It's successfully built, right? Now, my local variables from the last time I used the debugger are sitting here. I still have an I have an X, but I don't have a Y. Okay. Don't know why that isn't letting me delete this. Oh, maybe I don't want to use 16.01. Maybe I'll go back to code blocks 13.12. Let's see what happens if I type 12.3 space 45.6 space 789, hit the enter key. All right. So it went ahead and erased that information from the last time I used the debugger. It filled in my variables I, X, and Y from this program. So now you can see, remember the first thing we typed in was 12.3. That should have been stored in X. See what's in X's memory? 12.3. Right. All right, see what's in, then the next thing we wanted to read is an integer %D. Right, we want to store that in I. So we read in the 12.3. Remember, we were sitting here in the input stream saying, well, let's skip over any leading white space. And let's look for an integer. Okay, 45, that's an integer. You can see then that 45 was stored in I. Right, this period stopped it from reading when it was looking for an integer and said, oh, okay, now %F says I should look for a floating point number. Well, 0.6 was that floating point number because when it encountered this space, it stopped reading and it stored 0.6 inside Y. Right. Once again, these inaccuracies on these decimal points that are out to so many places are due to the way that floating points information is stored in memory. Right. In this case, don't worry about this information being out here. Just understand that it read that as 0.6. This is 12.3, and this is 45. The rest of the information here is still sitting out on the string. Okay, and then I'm going to stop debugging. Right. Now, if I wanted to make another variable to show you that information is still sitting out on the string, we could add another integer because I still have an int sitting out on the string. So I'm going to call this other stuff. Right? And now let's try to write a second scanf. And because I made other stuff an integer variable, let's just go ahead and see if we can store other stuff in the string. All right, so here I place the cursor here. I'm going to right click and say run to cursor. You could go to the debug menu and find run to cursor as well. All right, we're going to type the same things we did before. 12.3 space 45.6 space 789, enter key. All right, so notice then, right, we have the same information as before in our variables because I typed the same thing. Other stuff, what it shows there is just the garbage that happens to be in memory in that location. Now, if I want to execute this line of code, I could put my cursor down here and do a run to cursor. Otherwise, I can choose from one of these menu options up here, right? Or I can go to the debug menu itself and I can say execute the next line. Right, so next line was this scanf. Well, because there was information already on the keyboard, it didn't sit and wait for me to type something. It actually read in that 789. Right, it skipped over the leading white space and read the 789 into other stuff and stored it there. So that was just to illustrate that that information is still sitting out there in the buffer. We'll get exposure to this semester as we learn, as we use scanf in programs where we try to read in multiple items. All right, so here I'm just going to stop the debugger. All right, now let's take a look at what happened. What if I made other stuff? I made it an integer before. What if I made it a float instead of an integer? So I need to change this %D to a %F. And I'm going to put my cursor down here at return 0. I'm going to say run to cursor. All right, now we're going to type the same thing. We're going to type 12.3 space 45.6 space 789, hit the enter key. And notice we got the same information here as well. Yeah, I'm wondering why that isn't showing that as a floating point number. Let me stop the debugger. Let me clean the workspace. Let's rebuild. Run to cursor here. All right. So I placed my cursor right before this scanf. We're still going to type the 12.3 space 45.6 space 789. All right. Now, because I cleaned the environment, it recognized other stuff was now afloat. Notice it has that garbage in its memory. All right, run to cursor means it executed this scanf. It stored these pieces of information in I, X, and Y. It hasn't executed this line of code. So next line, right, if we hit that, we'll do that. It actually reads it in and shows it as 789. It really should be showing it as 789.0000. For some reason, it's just not doing it here in the debugger environment. Not quite sure why that's happening. Try to illustrate a point, and I get another problem. Welcome to the wide world of programming. But you get the idea of how it reads and pattern matches from the buffer. All right, that's the end of exercise 4. We'll go on and do 5 next.